Welcome to myprojectbazaar.com. Our product title is Low Power ECG-Based Processor for Predicting Ventricular Arrhythmia. Now we are going to discuss about our product abstract. So our proposed the paper presents the design is a fully integrated net program ECG signal processor for predicting a ventricular arrhythmia using a unique set of ECG features and a navy bias classifiers, real-time and adaptive techniques for the detection and the delineation of the PQRS waves were investigated to extract the points. Those techniques are robust to any variation in the ECG signals with a high sensitivity and precision. Two database of the heart signals recording from the MIT and American Heart Association were used. The validation set of evaluated the performance of the processor based on application specified integrated circuits ASIC simulation results. The overall classification accuracy was found that sample validation of architecture proposed implementations recently, due to the remarkable advancement of technology, the development of dedicated hardware for accurate ECG analysis and classification in real time has become possible. The main requirement are low power consumption and low energy operation in order to have longer battery lifetime along with a small area for variability. Many attempts success to implement ECG signals processing and classification may be biased classifications in the ECG signals identification of the heart disease with the display on the silence process. Now we are going to discuss about our product flow diagram. This is our flow for the pros the given input for the ECG signals. So we are getting from the inputs ECG signals from MATLAB to using the MATLAB tool and to filter the ECG signals. So we have used filtering the low pass filter and high pass filters. So we denoise process are pre-processing functions. Also we have this process and to apply the low pass filters and MATLAB tool silence software. So three blocks we are using the MATLAB 2013 version, and then we are going to the DFT based on the QoS detection feature extension processor. So in this feature extension parts we are using the DFT discrete Fourier transformer using the extract the values, and then we are using the Gaussian kernel unit to approximate the multiplexers. So this process we have developed the silence software. The classification process we have done on the cardiac based the architectures. So this and then we are going to the scaling functions. So this is the error detection functions. We are going to database support vector SVM process, and then with the pre-processing works of the support vectors, then threshold value set. So we are getting the heart rate value one set a time that defined like for example 80 to 120 is a normal, and then we have to increase the value heartbeat in abnormal. That's how we are going to the classify the SVM using the SVM classifiers. So what is the type of the disease in the abnormal tachycardia, bradycardia? See in this paper we have the arrhythmia only is defined. So now, but now I'm going to discuss give the output for the abnormal disease for the arrhythmia, tachycardia, bradycardia. So like more than disease for that output, and then final matching the result for the overlap the database samples, and then get the final live threading results. So in this all the process we are going to the develop in the silence, and then match the values on the what type of the disease it display in the silence software. Now we are going to discuss about our product running procedure. This is the MATLAB tool for 2013. Here only run the how do we get the input signals from here only. So develop the main function codings. This is the main function .m file coding. This coding will describe that how we will get input signals, read the signals. So only we are using in the MATLAB. So I am going to running the processor, running the coding. The data set is also is given. So whatever data we are giving that, so I'm going to select the one MATLAB file data set. So I'm selected. The output displays the input ECG signals with a noise, and then ECG signals without noise. So this is the input signal, input ECG signals with a noise, and then this is the ECG signals without noise. So this coding I'm described that how to get the select and signals, and then how to plots are given, and then another coding we have train features we are giving so we are giving the lot more of number of data. So is how to we direct it, how to use giving the classify the process of noise, and process we are giving that, and then automatically open the Xilinx software. So just we are going to running the process, and then we get the output and the what type of the we are using the architecture name VLSI. We are using more classifiers, how to the classify feature extraction, and how to classify the process. So we are using the SVM classifiers. So this architecture is built in the Xilinx software, and then this is open. So okay, now we are open the Xilinx software. So this is a coding, and I'm going to running the processor. This is what type of input we are giving the data signals, and what type of signals is what type of this is occurred in the signals is displayed in the Xilinx software. So now I'm going to running this process. The process immediately behavioral models completely successfully. The iSIM process automatically open. This is the iSIM. What is the graphical values given there, and then I'm going the clock and output. This is a what type of characters is displayed. So this is the clock we have given here. So force clock. So lead aging values is 0, and trailing edge value is 1, and periods is 1000 nanosecond. So all inputs are given and apply and OK this, and now I'm going to running this process. So after running the coding, we are going to split the signals. So we are using the zoom panel. The process is running. I'm going to the output is displayed in the second panel's bradycardia. So our main objectives, what type of disease, how to we feature ECG feature extraction, and how to we classify the process, and then how will what type of disease in the ECG signals in abnormal persons. So we have mainly to abnormal and abnormal, and then abnormal is going to the what type of disease is identified that. So our objectives in the process in the have given the signals, it have has bradycardia disease have it. Thank you.